Greetings and welcome, friendliest of friends. We are in section 10.2 today, and we are finding arc measures, which I assure you will not be measured in cubits today. Oh man, wow. All right, a central angle of a circle is an angle whose vertex is the center of the circle in the diagram. Angle ACB is a central angle of circle C. All right, if the measure of angle ACB is less than 180 degrees, then the points on circle C that lie in the interior of, on circle C, yeah, like so, highlighted in the teal, I don't know, sky blue, aqua, one of those points form a minor arc with the endpoints A and B. So this is not a segment, it is a minor arc. All right, and the points on circle C that do not lie in the minor arc form a major arc. In this case, right, ADC is the major arc. And I have to throw in another point there just so I make sure I know that I'm taking the long way around this Pac-Man. And then a semicircle is an arc where the endpoints are the endpoints of a diameter. Minor arcs are named by their endpoints. A minor arc associated with the angle ACB is named AB, all right? And you've got like the little arc over it. All right, so if you guys can see that, right? You got that. And a major arc requires 3 points in order to name it. Like so. There we go. Good times, it's an easy lesson today. Aren't you happy? We're doing easy stuff today. All right. So, here we go. Measuring arcs. The measure of a minor arc is the measure of its central angle. So you measure arcs by their degrees. The measure of arc AB is read, listed, labeled with a little M in front. Right, Haley? And that little M, just like we used to put an M in front of an angle sign, is read as the measure of arc AB. The measure of the entire circle is 360 degrees, and the measure of a major arc is the difference of 360 and its related minor arc. All right, yeah, so I see that right there, yeah. 360 minus the minor arc will equal the major arc. Wow, I'm excited about this, guys. Circles. If I just said arc AB, you would assume it was the shorter distance, not the bigger distance. So that's why you have to throw D in there, just to be like, yeah, you're going to take a detour on this trip first. That's all. That's the only reason. All right, let's see. Okay, here we go. You guys help me out with this. Let's have Ty. Ty, you help me out with example 1, part A. It says, find the measure of each arc of circle P, where RT is the diameter. All right, so RS. What are you thinking, Ty? What is the measure of arc RS? 110 degrees. Perfect. Let's see. Let's have Aiden of Diamonds help me out with RTS, also known as real-time strategy, one of my favorite genres of video juegos. Am I right? RTS looks like it's going to be the major arc. So, Aiden, what are you thinking? And how could you find that? What was your answer, sorry? 250. How'd you come across that? I like it. Yeah, subtract 110 from 360. Yeah, I'm okay. Yep. Give it a middle name. Yeah. That's an interesting theory. Interesting. Interesting, yeah. If it was always listed in clockwise order, I could see that, maybe. It's an interesting strategy. I mean, mathematicians have developed a standard that they're going to go by now, but if you were the one that invented or discovered arcs, rather, I could see that. Let's see, and let's have another person. Let's have, Aiden, double Aiden score today. Aiden M, RST. What's the measure of that arc? And notice this clue right here. RT is a diameter. So what are you thinking? Yes. And open up the floor to anyone. What do we call that kind of arc? A semicircle. Wonderful. Yeah, that's what we call it. All right. Oh, wow, guys, I love this. I love how, like, methodic geometry is. It's classic. Let's see. Here it says two arcs of the same circle are adjacent arcs when they intersect at exactly one point. And guess what? You can add the measures of two adjacent arcs. Well, if their units are the same, or if they're like terms in algebra, you can add anything you want. Did my mouse die? It might have. And arc addition postulate, right? So in going over our addition postulates, I believe we've had segment addition postulate, angle addition postulate. I think we've mentioned area addition postulate. And now we have arc addition postulate. Pretty much just have any old addition postulate that you want, as long as it's things of stuff, where the big thing is equal to the sum of the non-overlapping littler things, is the idea. So let's use some arc addition postulate for example 2. All right, let's see. Let's go through this quick. Find the measure of each arc. Isaiah, help me out for GE, General Electric. What is the measure of Isaiah, you said 120. Also, happy birthday. Bonus answerer. All right, so the way we found that out was that GE is equal to the sum of GH and HE, 120 degrees. How about Evan for part B? So the measure of Jeff. Let's see. GEF. So I can use this information. Yeah, it looks like it's going to be 230 degrees. I like it. I like it. And let's see. Haley. GF. Oh, wow. Now, this one's a little trickier. How'd you get that? I agree. And because this only had 2 letters, we assumed it was the minor arc, right? That's what we would have assumed, and I agree. Well done, well done. Ooh, example 3. Ooh, mine has color on it. I don't know why I would have made a pie chart labeling the degrees. I think I would have made a pie chart labeling percentages. Whom would you rather meet? Why is mathematician not here? I guess that would be under other. Or is there a cross-section between mathematician actors like our friend Robert? Kanye. Okay. I would be a fan of meeting Sean Plott. He's my favorite mathematician slash video game professional slash StarCraft caster. Day 9 is his... Yeah. Like some of his best of. I don't know, sometimes his channel gets, he gets a little flavorful with his language beyond, It says, a recent survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or other person. The circle graph shows the results below. Find the indicated arc measures. All right, so AC... looks like I would just add those together. So that's going to be what? 137? You guys help me out with this one if I'm wrong. Let's see, ACD. So A to C to D. So that's 137 plus the 83. So that's 140. Gentlemen, Isaiah, you with us? So let's see. So if I want to find this arc, Isaiah, I'm going to add the 137 I had plus the 83. And so 140 plus 80, 220. You with me? All right, cool. 360 minus, yeah, that's, yeah, you could work with the opposite of that one there, 360 minus that. Let's see, ADC, so that's going to be 79 plus 61, that's 80 plus 60, 140 plus 83. Wow. Was that 223 or 243? What did I do in my head? All right, thank you. And guys, actually, I think I'm going to modify this question in a moment. And then other, let's see, EBD, sorry, EBD. This one would be the classic 360 minus 61, so that's going to be 299 degrees. Now, what is more interesting is if you were creating a poster of a pie chart, and if you had the percentages of these, and then I had to say, figure out, well, actually, let's ask that question. What percent of people wanted to meet their favorite musician? No. So I know that 108 degrees of how many degrees are in a circle? 360 is going to equal their unknown percent out of what number? 100. Right? So it's a third? All right. You could cross multiply this. You could do all sorts of things. We'll cross multiply real quick. I would multiply both sides by 100 to solve for P. But I get P is equal to 30%. So normally, we would have had the data in percentage form, gentlemen. And then I would have had to convert those to degrees in order to draw the pie chart. But in the era of Google Sheets and just making pie charts, it'll do all that for you. All right, let's keep cruising, Mr. Water. You're taking too much time. I've got 5 minutes I want to finish this video in. Less, maybe. Two circles are congruent circles if and only if a rigid motion or composition of rigid motions maps one circle onto the other. And so circles are congruent if they have the same dimensions. And the only dimension that matters to us would be the radius, or you could say two diameters are congruent as well. And it turns out two arcs are congruent. Let's see. Lots of little facts today that aren't like real difficult. They're just a lot of them. Two arcs are congruent if and only if they have the same measure and they are arcs of the same circle or of congruent circles. All right, so congruent arcs are not... actually, think about it this way, Isaiah. Congruent arcs, you cannot use def of Cong for arcs. That just because their measures are equal does not mean the arcs are congruent. So you could have two arcs that are 30-degree arcs, but are not congruent because 30 degrees on two different sized circles are not going to produce congruent arcs. So let's see. Congruent, Jack, central angles theorem. Right, in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. As so. So here we go, example 4. Man, lots of stuff, lots of stuff. This one's quick, though. Which, by the way, the other accelerated class is doing 2 lessons today. But I was like, I'm just going to do 1. Even though this is easy, I feel like there's a lot of information. Tell whether the... Tell whether the blue arcs are congruent. Explain why or why not. All right, these arcs on the same circle? Yes. Do they have the same measure? Yes. So then arc CD, actually I'll write this in my classic yellow, is congruent to arc EF because they're on the same circle and they have equal measures. How about B? Arc RS and TU? No. They both have a 90-degree measure, but they are not on the same circle. And these two, UV, is going to be congruent to arc YZ. Because even though they're on different circles, they're congruent circles because notice their radii are the same and they have the same measure. Why not B? Those two circles are congruent. Notice the circles have their radii. Jack, Isaiah, quiet please. Yeah, but one person at a time. Anthony, yes? These circles are congruent because both of their radii were measured with the congruent tick mark to each other. And if their radii are congruent, then the circles themselves are congruent. All right. Similar circles theorem. Guys, this is going to blow your mind. What? That's crazy. I'm going to skip the proof today. On the test. Nah. You just basically map two circles onto each other and then dilate one so that the radius becomes the radius of the other and it works out. And then two arcs are similar if and only if they have the same measure. All congruent arcs are similar, but not all similar arcs are congruent. All right. Thanks for watching, Internet friends. Have a great day. Bye-bye.